Okay, next question, 2003 Junior Cert Higher Project Maths paper. Is a multiplier is a variable used by economists to measure the effect of increase in spending in the economy. One version of a multiplier is m equals 1 over s plus p, where m is the multiplier, s relates to savings and p relates to imports. Calculate the value of m if s equals 0.2 and p equals 0.1. Well, m therefore is equal to 1 divided by 0.2 plus 0.1, which is 1 divided by 0.3. Put that into the calculator. What I get is 1 divided by 0.3. And I get 10 over 3, or 3.333. So I'll put down as 10 over 3, or 3.33. Okay. Explain the effect on the size of m if the value of p increases. Well, m equals 1 over s plus p. Now what I'm going to do is I'm going to put in p as a bigger number. Okay, I'm going to keep s the same, and I'm going to put p as a bigger number. So p, I'm going to let p be equal to 0.5 this time. Okay, so what's going to become is going to be 1 divided by 0.7 this time around. So 1 divided by 0.7, and this time it's 10 over 7, which is 1.42. So as p increases, the value of m gets smaller. So just test it out. Just put in a bigger number and see what happens. So you're basically increasing the size of the denominator. The bigger the denominator, the smaller the number. Okay? Finally, sometimes the above formula is used to calculate p. Rearrange the formula to make p its subject. Okay, so m equals 1 over s plus p. What we're going to do is we're going to cross multiply first, and we're going to bring the s plus p up together. So we're going to get m multiplied by whatever s plus p is must be equal to 1. We're going to multiply out, and we get ms plus mp equals 1. Bring the mp over the other side, so we're going to get ms equals, sorry, not the mp, the ms over the other side, excuse me. So bring the ms over the other side, and what we get is 1 minus mp equals 1 minus ms. And then finally divide by the m to get p on its own. So we're going to get 1 minus ms all over m. Now another way of doing it would have been to do this. Okay, secondary way to do it would have been to this. It would have been to bring the m down, and what we would have got was s plus p equals 1 over m, and then to bring the s over the other side, and we would have got 1 over m minus s. And as you can see, it's actually the same answer, because p would be, if I broke it up into two fractions like this, it's actually the same thing, and then I would have got 1 over m minus s, because those two m's will be cancelled. So it's the same answer. Okay, in the same way that 3 halves, 3 plus 5 over 2 is 8 over 2. It's the same thing as me saying 3 plus 5 all over 2. So you can join the two fractions together when I'm adding or subtracting. Okay? So it's the same deal. Okay guys, next question. Question 10. If n equals 7, find the value of 2n and 2n plus 1. Okie dokie. So n equals 7, so 2n would be 2 multiplied by 7, which is 14, and then 2n plus 1 is going to be 14 plus 1, which equals 15. If x represents an even number, explain why x plus 2 is the next even number. Well, what happens is, think of the lowest even number you can. Okay? So what we know about the lowest even number is 2 is the lowest even number, and to get to the next even number, which is 4, we must add 2 onto 2. Okay? So when you're on an even number, adding 2 to that number will always get you the next even number. Okay. If 1/3 the smaller result, if 1/3 the smaller even number is subtracted from half a larger even number, the result is x. The result is a. Find the value of x. Okay. So when you're on an even number, so when x is the even number, adding 2 to that even number will always get you the next even number. And what this one is, x plus 2 is the bigger one, and x is smaller. So let's look at this. When 1/3 the smaller even number, so 1/3 the smaller even number is the smaller even number divided by 3, is subtracted from half the larger even number. So half the larger even number is that number divided by 2. You take away the smaller even number divided by 3, the result is 8. Now we're going to solve this. Once again, 6 is going to be the lowest common denominator, so we're going to multiply the top and bottom by 2 for this one here, and this one here we're going to multiply the top and bottom by 3, and what we'll get here is this. We're going to get 3x plus 6, we're going to get minus 2x all over 6 equals 8, and then what we're going to get is 3x minus 2x is 1x. 1x plus 6 over 6 equals 48, or so equals 8. Multiply 6 up, we're going to get x plus 6 equals 48. Bring across the 6, and we're going to get x equals 48 minus 6, x equals 42. Now, if 42 is the smaller number, the bigger number is 44. Okay, now remember, half the bigger number is 22, 1/3 the smaller number is 14, 22 minus 14 is 8. That's verifying my answer, so I know I'm correct. Okay, question 11. Solve the following inequality and show the solution on the number line. Well, what we got to do with this is we got to split it in half. Okay, so what we're going to get is minus 2 less than or equal to a half x minus 3, and then a half x minus 3 is less than 1. X is an element of n, so x has to be 1, 2, 3 and above. So let's figure this out. First of all, bring the 3 out the other side, and we get minus, this is in red, sorry, minus 2 plus 3 is less than or equal to a half x. 1 is less than or equal to a half x. Spin it around in the same way that 2 is smaller than 3, 3 is bigger than 2. So we can spin it around and we get a half x is greater than or equal to 1. Bring the 2 up and we get x is greater than or equal to 2. On this side, bring the 3 out the other side, and we're going to get is a half x is less than 4. A half x, bring up to 2, x is less than 8. Now what this means is, on the number line, show the solution on the number line, okay? So on the number line, what this will mean is that it will mean that 8 isn't included, but 2 is, and I'll tell you why now. Okay. 8, 6, 4, 2, and 0. Okay, you're not meant to shade it in. The reason why you're not meant to shade it in is because decimals and fractions aren't included. Okay, x is greater than or equal to 2. 2 is included. 3 is included. 4 is included. 5 is included. 6 included. 7 is included, but 8 isn't. And you're not to mark anything on 8 because it's just nothing between 7 and 8 is included. Okay, so the answers are going to be this answer 2, 3, 4, 5, 6, and 7. Okay, so that's your answer there, and that's on the number line. Okay, now 11b. Josephine hopes to go to college. She has saved €3,000. She will attend college for 32 weeks in her first year. She plans to have at least 800 left at the end of the year. If she spends X euro each week, write an inequality represent her spending during the year. Okay. So, what happens is she has €3,000 and she plans to have 800 left. 3,000 minus 800 is 2,200. She is not allowed to spend more than 2,200. She's going to college for 32 weeks. She spends X euro each week, so her total spending is going to be 32 multiplied by X. This 32 multiplied by X has to be less than or equal to 2,200. And the reason for this is the 2,200 is that she's not allowed to spend more than 2,200. So we're going to get 2,200 divided by 32. And what we get there is 68.75. So she's not allowed to spend more than 68.75 euro a week. Hence or otherwise, find the maximum amount Josephine can spend each week. Well, that answer is already done because it's going to be 32x is less than 2,200, and then x is going to be less than or equal to 68.75. This means that the maximum she can spend is 68.75 euro. She's not allowed to spend more than this, otherwise she spends more than 2,200 euro. So it's already solved. Okay, question 12. Irish Sports Promotions have designed a company logo. The actual size of the logo is shown here. Write down the dimensions of the logo to the nearest millimeters below. Well, so guys, in the test what you'd be doing is you're going to be measuring it with a ruler, okay? So you come across with your ruler and measure it. Now, when you measure this, it should turn out to be 27 millimeters, which is 2.7 centimeters across. And it should measure 1.5 centimeters up, which is 15 millimeters. So 15 millimeters, width is 27 and height is 15. The company wants to enlarge this logo in order to put it at the side of its fan. The space available for the height of the logo on each side of the fan is a width of 2 meters and a height of 1 meter. If the company wants to keep the same width to height ratio as the original logo, calculate the dimensions of the largest logo that will fit onto the side of the van. Okay, well, put it this way. Its new sign has a width of height of 1 and a width of 2. Okay, so it has a ratio of, its height to width ratio is going to be 1 is to 2. Okay, that's for the van. Now, the height to width ratio of the original is going to be 15 is to 27. Okay, and this here is not quite a 1 to 2 ratio. Okay, it's actually underneath the 1 to 2 ratio. So if we scale this up a little, 1 to 2 is the same thing as 15 to 30. And the problem here before that is 14 is to 28 when you multiply with 14, and 13 is to 26. What's going to happen is you're going to run out of width before you run out of height. Okay? So what's going to happen is you're only going to be able to fit a 13 and 26 across. Okay? So what's happening is the height of the logo is going to fit, but the width won't. So the height is going to be 1000 millimeters high, and now we have to find out what the width is. Okay, so in effect what's going to happen is an object that was 15 millimeters across, so if you take this as an example, this rectangle here, right, it was 15 millimeters across, and now it's going to be extended in the same ratio until it's basically, it was 15 and it's going to be extended in the same ratio until it's 1000 millimeters. Now the reason why it's 1000 millimeters is because 1 meter is the same thing as 100 centimeters, and 100 centimeters is the same thing as 1000 millimeters. Okay, so 15 millimeters gets increased to 1000 millimeters. So how many times bigger is it now? So it's going to be 1000 divided by 15. So its height is now 200 over 3 times bigger. So the height is going to be 200 over 3 times bigger, and therefore so is the width. So the 27 millimeter width is now going to be 200 over 3 times bigger. So we're going to multiply 200 over 3 by 27, and what we get is the new width is 1800 millimeters. Okay, and that's the biggest that will fit in the side of the van, 1.8 meters. Okay. Alright guys, next question. Question 13. ABCD is a rectangle. AEFD is a square. AD equals 1. This means EF equals 1. Means CB equals 1. DC is X. So D all the way to C is X. Okay? Now we're told AEFD is has to be a square. Okay? So this means that this is 1 and this is 1. Okay? And if this whole thing is X, this means that this length here, F to C, has to be X minus 1. Alright? And that means that because when you add it together, you need to get X. So 1 plus X minus 1 equals X. Because D to E is 1, F to E is 1, because AEFD is a square. This here is a square. Okay? So write EB in terms of X, it's going to be X minus 1. Okay? Now the next thing it's asked me is, if AB over AD equals EF over EB, find the distance X. So what we're going to get is AB, A to B is X, A to D is 1, E to F is also 1, and E to B is X minus 1. Going to do now is we're going to cross multiply, and what we get is X bracket X minus 1 equals 1 multiplied by 1. We're going to get X squared minus 1X. I'm going to bring this 1 over to your side because 1 multiplied by 1 is 1. We're going to get a minus 1 equals 0. Answer correct to 2 decimal places. If you're answering correct to 2 decimal places, it means that you're more than likely going to be using the minus b formula. Okay? And what we need to do now is we need to find out what the values are. Now, in the minus b formula in your notes, you're going to be given this formula. A is whatever number comes in front of the x squared, so A equals 1. B is whatever number comes in front of the y squared, which is minus 1. C is whatever number comes last, which is minus 1. We're going to put them all in. Minus b is going to be plus 1, and we're going to see what happens. So we're going to get plus 1 plus or minus the square root of b squared, which is minus 1 squared minus 4 bracket 1 bracket minus 1 all over 2 multiplied by 1. What we'll get next is plus 1 plus or minus, and we're going to put this part here into the calculator only. Square root of minus 1 squared minus 4 bracket 1 bracket minus 1 close bracket, and we get root 5. So it's going to be 1 plus or minus root 5 over 2. Now this here is surd form and not decimal form. So we have to do finally is we have to do 1 plus root 5 all over 2 and 1 minus root 5 all over 2. So press the fraction button, 1 plus root 5 all over 2. And what we get here is 1.62, or what does it want to correct two decimal places. So it's 1.618, which is going to round up to 1.62. And then the other one is going to be 1 minus root 5. Which is going to be minus 0.62. Okay, so 1.62 and minus 0.62 are the two answers there. Now, the trick is with distances, distance can never be negative. So it means one of these answers has to be written off. And it can never be negative, so therefore the width is 1.62 centimeters. Okay? Because you can't have a negative answer for that. Okay guys, question 4, part in. Okay? Now, investigate whether the pattern in the table below is linear, quadratic or exponential. Now, there's something that you need to know about linear. Linears go up by the same amount each time. Okay, so 2, 4, 10, 14, 18, okay? Now what happens is, it goes up in 4s every time. So 4, if you take them away from each other, so 6 minus 2 is 4, 10 minus 6, 4, 14 minus 10, 4, 18 minus 4, 4. The first difference is always the same. This means it's linear. In a quadratic formula, what you'd get is in a quadratic formula, the second difference is always the same. Okay, so this was an example of a linear where the gap between each number is the same. Okay, in this one we can see that the gaps aren't the same. It goes 10. So the first gap is going up as 6 because 9 minus 3 is 6. Second gap is 10. Third gap is 14. And then 15 minus 31 is 18. Now the problem is here is that like the first difference is different, but the second difference, 10 minus 4, 10 minus 6 is 4, 14 minus 10 is 4, 18 minus 4 is 4. When the second difference is the same, it's a quadratic expression. Okay? It's quadratic. Now the last type of one is exponential. Exponential will be example like this: 2, 4, 8, 16, 32, 64. You can see that it's being multiplied by the same amount each time, and that's an example of an exponential function. Now what we need to do is we'll first test if it's linear. Now to test if it's linear, we need to see what is the difference between each one. So the difference between term 1, we're going to go for the first difference. The first difference is 6a has been added on to go from 2a to 8a. Minus b then turns into minus 2b, which means it's minus b in the second one. 2c remains constant. That's the first difference between term 1 and term 2. Let's take away term 3 minus term 2, and we look at 8a turns into 18a, and that's going to get us 10a. Minus 2b turns into minus 3b, which is minus b. The next one, 18a turns into 32a. Okay? So 18a, sorry about that, 18a turns into 32a, which is 14a And then 3b minus 3b turns into minus 4b, which is 14a minus b. And that's the difference between term 3 and term 4. And then finally the difference between term 5 and term 4 is going to be 50a minus 32a, which is 18a. And then minus 5b minus minus 4b will obviously give you another minus b. And once again, no difference in 2c. Now the first difference shows that it's not a linear, because in a linear the first difference is always the same. We can now cross off linear as its as what type of sequence it is, or pattern. Okay. Next we're going to do the second difference, which will be in green, and the second difference is going to be 6a minus b turns into 10a minus b. The only difference between the two of them is we added on 4a. The difference between 10a minus b and 14a minus b is once again adding on 4a. And finally, the difference between 18a minus b and 14a minus b is going to be 4a. The second difference is constant, which means it's the same value each time. This means it's a quadratic pattern or quadratic sequence. Okay, so that's it done there. Now finally, question 15. There's three functions. The three functions are shown here. F of x, g of x, and h of x are defined as follows. Solve f of x equals 0. So to solve f of x equals 0, we have 2x squared plus x minus 6 equals 0. Reference number, minus 2 and minus 6 gives us a reference number of minus 12. Okay? Minus 12 means that the reference number should be plus 4 minus 3. So we're going to get 2x squared plus 4x minus 3x minus 6 equals 0. We're going to take out 2x and we get 2x bracket x plus 2 minus 3 bracket x plus 2 equals 0. And then we get 2x minus 3 into x plus 2 equals 0. Putting the dots here, and what we should get is 2x minus 3 equals 0, 2x equals 3, x equals 3 over 2. The next one's going to be x equals minus 2. Next one, solve g of x. Well, g of x is x squared minus 6x plus 9 equals 0. Reference number of 9. And what we're going to get there is it's going to be minus 3 by minus 3. Adds together to give you minus 6. So it's going to be x minus 3. X minus 3 equals 0. And then what we're going to have is x minus 3 equals 0, or x minus 3 equals 0, x equals 3, x equals 3. So that is the answer for g of x, okay? Now, the last one, solve h of x equals 0. So it's going to be x squared minus 2x equals 0. And what we're going to get next is it's going to be x bracket x minus 2 equals 0. So either the first number equals 0 or the second number equals 0. And x equals 2. Okay, 15 part 2. Okay, now the thing to remember about functions is, okay, this function here is a u-shaped function because it's u-shaped, okay, because it has a positive x squared. Now, when you solve a function equal to 0, what it tells you about this function is it tells you where it hits the x-axis, okay? So if this one here tells you that it hits the x-axis at minus 2, and it'll also tell you that it'll hit the positive part at 3 over 2. This one here has the same value for when it hits the x-axis, x equals 3. Now, because x equals 3 is located at the same point, it means that this graph only touches it once. And the final graph, sorry, we'll put this one in black here. So this is the black equation f of x. This is the red equation g of x, because it only hits once. And this one is the blue graph h of x. Now for h of x, okay, it hits the y value is 0 when x equals 0, which means it's here, and also when x equals 2. Once again, it's u-shaped because of the positive x squared. So this is the shape of the graphs, okay? Now, when we look down the next question, okay, in the table below shows sketches of 6 different functions. 3 of the sketches belong to the 3 functions from part A. Write f of x, g of x, or h of x into the box underneath the correct sketch for each of the 3 functions. Well, the first thing we can get rid of is they all have a positive x squared. So the n-shaped graphs cannot be the right answer. Okay? The next one we're looking for is, the easiest one to spot is the red one, which is going to be g of x. G of x only touches the axis once. This because it has the same answer twice when its y value is equal to 0. When its y value equals 0, it only happens when x equals 3. Okay, so we go down and we look at here, and this part here is going to be g of x because the x value is positive and it only touches once. Okay, and the next one we're going to look for h of x, where it crosses the axis at x equals 0 and x equals 2. So x equals 0, x equals 2, this one here is h of x. And then finally we have a choice between diagram 3 and diagram 4. In diagram 4 it says x equals 0 because that's where the y value equals 0, but this is not the case for the function f of x equals 0. When the output equals 0, the input has to be equal to -2 or 3 over 2. And this will be this one here, which is f of x. Okay guys, that ends the end of this video. I hope it helped.